So let me first introduce you to the ultraviolet regime. Well, the ultraviolet, which is one of my favorites, goes through to 100 nanometers to 10 nanometers. So extremely small. And we can divide the ultraviolet section in three parts: the UVA, the UVB, and the UVC. So the UVA goes from 400 to 350 nanometers. The UVB goes through 315 to 280, and the last part goes to 280 to 200 nanometers. From 200 to 10 nanometers, it's what we call extreme ultraviolet. But the reason why I want to focus on these three parts is because now the sun, which is our main source of radiation, constantly emits all parts of the electromagnetic spectrum. It's the UVC part, at least components of this, it's completely absorbed from the ozone layer in the atmosphere, which means that it doesn't reach the surface where we live. However, the UVA can pass through the ozone layer completely intact, so we receive all of them. And a small portion, let's say 10% of the UVB, also managed to escape the ozone layer and to reach Earth. And because of this UV radiation, we use sunscreen to protect ourselves. And sunscreen are characterized by a SVP number, which is a sun protection factor, which is a measurement of how much solar energy, in this case UV radiation, is required to produce sunburn on our protected skin. So how does this work? Well, you can imagine that we have 100 photons and we didn't put sunscreen and we go on the beach. Well, all these 100 photons from the sun will go through the ozone layer and will eat us, and we'll get sunburned probably, especially if we go in July or August. But then instead of not using sunscreen, we use something like 15 as a sun factor. Well, 93% of that will get absorbed by the sunscreen, but 7 photons will still enter the skin. So what we do is to double it, and instead of using 15, use now 30. Then we will have a 97% protection, and so on. We can go to 50 protection, we can even go above 50. Why is this particularly important? Well, both UVA and UVB increase the risk of skin cancer. So it's very important that we protect ourselves, not only during summer, but throughout the entire year. And there is some very strict regulation in the European Union that says that a sunscreen should, of course, will always protect you from the UVB, but it should also have protection from the UVA, and this needs to be certified with a specific sticker on the sunscreen label. So if you use a broad spectrum sunscreen, you will be able to be protected from both UVA and UVB. Now, I didn't give you an example of research application for ultraviolet and visible spectroscopy are often combined. So with the UV spectroscopy, we can actually probe electronic transition, which you can see in this gift right here. So let's imagine that you have a nitrogen atom in this Bohr representation, and then you have a single electron in the lowest shell, which is the lowest energy possible. And then you kick it using the right wavelength, using UV visible light, and which means that you have absorption. But of course, this electron cannot exist in this excited state forever. So at a certain point, would also go back and will emit light. So you can either investigate this absorption or you can investigate this emission of light.